So this one was fairly straightforward, right? So I'll just put up the answer for those watching at home so you can copy it down. To go from velocity to acceleration, you take the derivative. Then if you're going backwards, you have the plus c, and you have to solve for c. Now, a ball is thrown upwards with an initial velocity of 64 feet per second, an initial height of 80 feet. How long will it take the ball to hit the ground? So, acceleration, because this is in feet, acceleration is going to be negative 32 feet per second. That's equivalent to the negative 9.8 is meters per second squared. But since we're dealing in feet, it's going to be negative 32 feet per second squared. Okay? Velocity, negative 32t plus c1, and then you plug it in. An initial velocity of 64 makes your C1 equal to 64. I think in a question like this, you would be given the acceleration, not something you'd have to necessarily have memorized, at least in feet per second squared. I can understand why you need it memorized in meters per second squared, because that's mainly what it's used for. Sometimes you get these questions that have a little bit of an American influence, and they have that feet per second squared. Then from here, we can integrate again. Now we have a plus C2. And since we were given an initial height of 80, we saw that C2 is 80. And something that's interesting, if you would look back to your grade 11 pre-calculus, they did some questions where they threw a ball up in the air and made a parabola. You're always going to have this with a height question involving gravity. The coefficient in front of the t squared is always going to be half of gravity. So if you look back to your grade 11 questions, you would either have, if there was an American influence, a negative 16. If there's an influence from anywhere else in the world where they would cut negative 9.8 in two, you'd sometimes have negative 4.9, and sometimes they'd round it like you had before to negative 5. Because they like a nice whole number. Whatever's in the coefficient in front of t, that's always your initial velocity. So in every single problem involving gravity and a ball being thrown up, whatever's in front of this t value is always your initial velocity. And of course, whatever's the constant is going to be your starting point. And this always happens.